So welcome to differential equations. Oh wait, I'm not doing that hard. No. What are we doing? Come on, it's right there. It is right there. Okay, it can't be that hard of a question. If that's a test question and it's right there, you're dying. You're just dying. All right, fantastic. So we're doing software development. We're doing a little bit of Python and stuff like that. So let's get a stomp on here. So remember this from last time? So what did we talk about? We talked about the key thing on this one was that your customers will often not really be quite sure what they want. And more importantly, as a software developer, your customers actually speak a completely different language than you do, right? They speak the customer's language. I'm running a retail store. I'm running a medical pharmacy. I'm running a company that sells tires. This is what I do for a living, and I will talk to you. I would like to sell more tires. I would like to keep track of my customers. I would like to be able to calculate things for missiles as they go off and stuff like that. They will not be talking to you in the language of computers. They're not going to be talking to you in the language of Python. Well, great, create some lists. I need you to sort the list. No, they're not going to talk to you that way, right? They're going to talk to you in the vocabulary that they use to run their business, right? And whose responsibility is it to translate from customer speak into computer speak? It's yours. If you're lucky, there's some fantastic department of people who do it, but let's assume for the purposes of this class, they don't exist. It is your responsibility, right? So you have to hear what they say, and you have to understand from a software point of view, they're not telling you the whole story, right? So they may tell you something, but you have to start thinking in your mind, wow, that's probably a whole bunch of individual things that actually have to be done, right? All right, cool. So there's two main concerns of any software project. So if I have a software project, and I find you, and say, I want you to be the software developer working on my project, in my mind, in the back of my mind, there's two things that are huge to me. I only have a limited amount of money I'm going to spend on this. You do not get $1 million for developing this. Now you're going to probably get half of that, right? Okay? And the other thing is, I need my software by some particular point in time. Christmas is coming up. I need to have my billing system updated. I need to have my rewards card software updated so it can support multiple rewards cards coming together and being put onto the same. Whatever the software change is, I need it by a particular date. So when I'm talking with you and giving you requirements and stuff like that, these are the things that are in the back of my head, okay? And so you need to understand from a software point of view, what's going to boost the cost of a software project? What's going to make it more expensive?
Less time.
Well, yeah, but what causes more time? If you have to... Complexity. And if it's more complex, you're going to have to do what?
Spend more time writing and testing.
That's exactly right. So more code means effectively more money, right? You can play some games and say, well, a little bit of code that's super complex, but whatever, I don't really care about that. But more code effectively means it's going to take you longer to write it, right? The longer it takes you to write your code, the more it's going to take you to test it and get it right and all that sort of stuff like that. So if I ask for just a little change, it shouldn't cost as much as if I ask for a big change, right? If I ask for a mild change to an existing program, it should be a pretty reasonable change, right? If I ask for a whole brand new program that doesn't exist, that's a much larger request on my part. As far as how long will it take, well, it comes down to how long it's going to take to actually do it, right? So if I'm asking for a little bit of code, you should be able to turn it around fairly quickly, right? But if I'm asking for a lot, obviously it's going to take a lot longer. So these are key things here. Due date for software, we'll do with that. All right, so we talked about software engineering. So when we're talking about that cost and that schedule stuff, it's going to fit into one of these 5 boxes, right? So requirements analysis, that can actually take a while, right? And it depends on how clear the customer is on what they actually want. If you're modifying existing software, it should go fairly quickly, right? Because they already got the software. So it's running, I use it on a daily basis, I know what it is, I want it to do something different. Okay, cool, that's a good discussion. I want the screen to be blue, I want you to collect some additional information, I want you to do some additional calculations. That's a great conversation to have. If I don't have the program, now we're sort of blue skying it, right? I think I'd like it to, all of a sudden things get a lot more complex. Your specification development, where you take what they're asking for and turn it into something that can actually be coded. And, you know, once again, it's going to depend on how much they're actually asking for. We know, obviously, software design, how long it's going to take you to code it will depend on what they're asking for. Testing and verification. So we all know about NASA. What does NASA do? Right, okay, so what's NASA known for? Do they do testing and verification? Why? Why do they do testing and verification? So people don't die, right? And NASA is known for being crazy testers. I mean, they're really crazy about testing. They will super duper duper test it because the possibility of anything going wrong, there's no real backup plan, right? And obviously, we all know they've had some problems and stuff like that, but they have a really pretty good track record, all things considered, okay? In the world of business, in the world that you live in, there's probably nobody's going to be willing to pay for NASA level testing, okay? But they are going to be willing to pay for some testing because what you deliver to them should work. And of course, maintenance is something that's ongoing, and that's an ongoing cost. So if I come to you and have you write some software for me, I better be budgeting for maintenance because I'm going to be paying you or somebody else forever to maintain that software because there will always be changes to it. Now remember, even if I don't change the software, what else could change that would cause that software to have to be changed? So I got a lump of software running on a computer, and I don't want to have any changes made to it. But yet, still you have to go and make changes to it. Why? What else changes in the world? Windows 8, Windows 10. Right? So operating systems change, right? If an operating system changes, do you think that could have an impact on the programs that run on it? Yeah. Wow, it's a Windows 95 program, works just fine. Well, great, that was a long time ago, right? So there's a bunch of, and by the way, if your software talks to another piece of software, if it interfaces with another piece of software, if the kids on the other piece of software change their software, could it impact yours? Right. So I'm happy with the software. It worked perfectly. Oh my God, I have to pay you to make some changes because other people did stuff. Google is famous for this. So what kind of products does Google make? They make Android. Well, they do make Android. What else do they make? They make the Chrome. They make Chrome. What else? What other products does Google make that you use every single day?
They have the search engine.
They have the search engine. Email. So Gmail. What else? YouTube. Keep going. Calendar. Keep going. Notes. A big one they make is Maps.
Yeah.
Google Maps. And there's a lot of people who've written programs that work with Google Maps. And Google's fairly famous for changing their Google Maps API, Application Programming Interface. And every time Google makes a change to that API, guess what all those other guys have to do? Scramble, right? And get their program to be updated so it can work with a brand new API. So things can happen. All right, this is important information. So, if you joined a software development team, they would tell you, we have a software design methodology that we use when we're creating software. And you would say, fantastic. What software design methodology do you have? In a lot of the world, they're going to use the magical word waterfall. Now, God's honest truth, they probably won't tell you God the waterfall because they're going to be a little embarrassed by it. Waterfall is old school. Okay? It's the way they did software development for years and years and years. There's newer, cooler, trendier stuff now. But waterfall's been around forever. So what is waterfall software development? It's pretty straightforward. It's a process. It's a process by which you develop software. Okay, it starts out by doing some research, sort of understanding what the customer actually wants. It sounds like a good place to start, right? Okay. Then you create a concept. You put something together that isn't by any means a complete solution, but sort of shows the customer what they want. You do some testing of the concept. You probably ask the customer, hey, is this really what you're looking for? Kind of deal? Once you get some basic buy-in from them, you design the software, you build it, which basically means get it ready for the customer, and then you deliver it to the customer. Is that pretty simple? Talk to the customer, make sure you got it right, do it, deliver it. That's what the waterfall technique is. Okay? And this is the way software has been developed for years and years, because it makes a great deal of sense, especially in terms of business. I'll set up a contract, I'll have my team work with you to figure out what you want me to do, I'll have my software people actually create it, I'll deliver it to you, and you will pay me. End of story. Okay? Now, there's some problems with the waterfall technique. And what it is, it's something called design debt. So if your customer starts here with what they'd like to have, as we go over time, and as the customer has a chance to think about what they've asked you to do, is there any possibility that they may change their mind?
Yes.
Right? Okay. So they're going to have new ideas as you're going through research, concept, test, design, build, release. Your customer's going to, oh, and by the way, don't have to do so well, but then there's some other stuff I'd like you to do. Okay, that's not cool. Oh yeah, don't do some other stuff because it's going to just bam. So customers are fickle and they will change their mind during the process. Now, if this is your design, you can handle some changes, right? If they tell you nice and early on in the process, hey, we'd like to make some changes, you can pretty much handle them. But there comes a point when you have to turn to your customer, and you don't actually say this, but you just think it really loudly, shut up. I got work to do, right? I'm going to create your software. And so you just start working on their stuff, and you don't hear them anymore, right? Because you can't. You have a software project that's due on a given date, and so you just sit down and start working on it, right? And what this causes is what we call waste, or really design waste, which is effectively things the customer would like to have worked into the product that you don't have time to do, right? You're not really talking with the customer. You're locked down and creating the software for them. Thank you very much. I'm going to deliver to you what you asked for a month, 2 months, a year, 2 years ago. Okay, pow. I understand you've changed your mind, but I'm not really set up to handle those changes, so I'm going to give you what you asked for a while ago, and then we can talk about making changes to it, right? So the problem with the waterfall technique is that as your customer changes their mind, there isn't really anything built into the process that will allow you to change what you're going to create for them. So what you'll actually deliver to them is something that they wanted a while ago, not necessarily what they wanted now. Does that all make sense? Okay? I'm sure you've had things like this happen to you in the past. Hey, yeah, your birthday's coming up. What kind of gift would you like to have? Oh, I'd really like to have a hat. Fantastic. 3 months go by. Oh, I don't want a hat. I want a sweater. Oops, too bad. You're getting a hat. Because I already ordered it, okay? And it's packaged, okay? All right. So there is a new, there's a different, is probably a better way of saying it, software design technique. It's called Agile. Agile is a 50-cent word. You'll see Agile sprinkled through just about every single software developer job description you ever see. Okay? Agile is a process. It has some terminology that goes along with it. Companies have gotten really excited about Agile. Is it because it's so great? No. Is it because it's new? Yeah. Is it because there's some problems with waterfall? Yes. So what's the gist behind Agile? Well, Agile starts out the same as waterfall. So you do some research. What does the customer really want? You throw together a concept. You test the concept to make sure that it's right. And then you talk with the customer. You show your concept to the customer. And you say, is this really what you want? Pretty much we're sort of the same as waterfall at this point in time. Customer says, yes, that's exactly what I want. Now here's where things get different in Agile. You then design a portion of the solution, not the whole thing, just a portion. A portion of the user interface, a portion of the output, maybe what 1 or 2 screens look like, what some of the calculations are. Doesn't even matter, just a portion. You break off a little chunk, you do it, you build it. This is the key. You go back and you show it to the customer. Okay? So you haven't worked on the whole project, you worked on a little part of it. You basically got that little part done. You go back to the customer and you say, hey, just wanted to check with you. Is this really what you wanted? More often than not, the customer will say, close, but not quite. I've had some changes. I've got a couple things I'd like to do differently. You say, not a big deal, because I'm getting ready to do another design and build cycle. Okay, so I can go back and make those changes, and oh, by the way, I'm going to break off another little section, I'm going to work on it, and when I'm done with that, I'm going to come back and have another talk with you and say, hey, is this what you really wanted? And so it goes on and on and on. You see there's a lot more interaction with the customer when you're doing agile development, right? You're also not going off, locking yourself in a room and just doing a big software project. Instead, what you're doing is you're breaking off chunks, you're working on the chunks. When you get done with the chunks, you go show them to the customer, and you get feedback from the customer. Oftentimes, when you get the feedback from the customer says, now that I've seen what you've done, here's what I really want. really? Couldn't you do that at the beginning? But what happens is you get a lot better feedback from the customer. Also means that you're going to be able to deliver a product that's a little bit closer to what the customer wants. So the customer starts here with what they want. Once again, they're just as flaky as they were before as far as changing their mind. But with Agile, because you're having these customer meetings, you're able to align what you're doing with what they want more closely. Now look, there's still going to be some waste. Okay, when they change their mind while you're off working on that stuff, you're not going to have a chance to make all the changes that they come up with, just because, remember, customers are crazy, right? But Agile gives you a chance to get a little bit closer to what the customer actually wants. So on one hand, we have waterfall, which is sort of the classic way of doing it. On the other hand, we have sort of an Agile technique. They are different. They both do produce software as an output, but do you understand what the difference between these two different methods are? Yeah. Make sense? Okay. Is one better than the other? You know, it's interesting. If you talk with young, hip developers, they'd say, oh, yeah, Agile, there you go. This is completely the way to go. You talk to some older developers who have been around for a little while, and you get sort of a different answer. And actually what people are starting to find out is that Agile, although very good, is not necessarily all that it's been cracked up to be. There are some problems with Agile. One of the biggest problems with Agile is, quick question, when does this end? Potentially never, right? And that's a problem. If I have to get my software done by Christmas, dear God in heaven, when does this end? Will you be done by Christmas if you're doing it via Agile? I don't know. You want me to be done by Christmas? Right? Now when we did this, hey, you gonna be done by Christmas? Damn straight, I'm going to have software for you by Christmas. Is it the software you want? Here it was, yeah, okay. Hey, you gonna have software for me by Christmas? Well, I'll have software. I'm not sure if I'm gonna be done, right? Look, and I'm simplifying it a little bit, but you get the gist of it. Agile doesn't really have a fixed stop date, and that's one of the problems with that. There is another type, it's called Lean. Now, Lean is actually a very interesting approach. If your customer doesn't have a clue as to what they really want, they know they want to have software for a product, but they don't really have any requirements for you yet. So say I'm in charge of Tesla Motors, and I've got a brand new car I'm getting ready to develop, and it's going to be a fuel cell car. And I need you to develop the fuel cell management system for me. Okay, so what kind of requirements in that fuel cell stuff do you have? Well, none yet, because we don't really have a fuel cell, but we do want you to develop the software. Okay, let's see how we're going to work on that one. So Lean has 3 parts to it. You build some software. You measure how it works, you learn from that, you go back and you build some more. So Lean really has to do with developing software when you don't have any firm requirements. Alright? So it's a real learning process. And yes, there's really no waste. There's no design waste. Because what's happening is you're going back and you're talking with your customers so often, you're constantly getting their feedback. Your development cycles are actually pretty short when you're doing a lean software development process. And the reason is because you're constantly going back to your customer, back and forth to your customer, because your customer doesn't really know what they want. Remember, these are very special circumstances. It's you're so far ahead of what they're actually trying to do that they can't give you firm requirements. They do know they want you to do software, and they have sort of a feel for what it's going to be like, but they can't give you really hard ones. So what you do is you develop some software that sort of looks like what you think they want. And they take a look at it and they go, well, that's pretty good. And what I really want is this, right? So everyone gets a little bit closer to what's going on. So if we take a look at waste, you can see under waterfall, there's a fair amount of design waste. Under Agile, there's less design waste. Less things the customer would like to have in the software that when you deliver it to them, doesn't actually show up. And in Lean, there's almost none, because you're always talking with the customer, and so they want to have something change, you've probably worked it into the product. So 3 different software design methodologies, waterfall, Agile, and Lean. They're all applicable to different circumstances. They all have their pluses and minuses. Are the differences clear in your mind at this point in time? Cool. All right. Remember, Agile is a hot 50-cent word. You look at any sort of job description, you're probably going to see we're an agile shop. You'll be part of an agile team. We use agile development. All they're really saying is we work on code quickly for a short period of time, and then we show it to the customer. We get the customer's feedback, and then we go back and do it all over. All right, big bang software development. All right, so you get the requirements from the customer. Yay! Magic coding happens. Fantastic, that's wonderful. And then, pow, you deliver it exactly to the customer, and it's exactly what they wanted. This was always sort of the fundamental philosophy behind waterfall techniques. Okay? The problem is magic doesn't happen nearly as often as it should in the real world. Doggone it. Quick show of hands, how many of you guys have had a ringing lottery ticket? Okay, first off, I think you have to be 21 to play the lottery. So what the hell are your hands doing up, okay? There should be no hands. 18?
Yeah.
Oh, what? So in the last X number of months you've been out playing the lottery? Yeah, right. Okay, I don't think so. Obviously, okay. All right. What I did not see is I did not see all hands in the class go up. So apparently not everybody wins the lottery every time. Is that a fair statement to make?
Yes.
Okay. Okay, big bang software doesn't often happen well. And in fact, if you read the paper, okay, if you read any of the trade rags in the IT field and stuff like that, what you're going to discover is more often than not, big projects, big IT projects fail. A really classic one is over in the UK, they have a national health system, which is actually a pretty cool concept, right? Thank you very much. Sort of like we are Obamacare, but even better because the government pays for more of it over there. The problem is it collects a whole bunch of data, and they were trying to standardize it. So they gave a contract to a company to come up with a single unified database for everybody who lives in England. Sounds like a massive IT project. It was. It was a horrible, terrible failure. And one of the reasons was because it was a big bang project. Okay, here's $1 zillion, and we'd like to have a single database. Fabulous! We're going to do some work, and bam, that's not what we want, right? So magic doesn't happen often enough in the real world, doesn't happen often enough in the software, so you have to be very careful if you find yourself in a big bang project. Why doesn't it work? Well, you did a lot of work, so congratulations. You get full credit for doing a lot of software work. Thank you very much. However, you didn't show your customers work until you were done. You thought you were building what the customer wanted with no feedback. Dang, I hate it when that happens. And now you'll have to do a lot of rework. Okay? Because ultimately that's what happens. So, another interesting point. What were the two main concerns about any software project from a customer point of view? One was cost, and the other one was time. Okay. So if you do big bang and you screw up, what's going to be impacted? And time, right? Because if I have to do rework, it's going to take me longer. If I have to do rework, you're going to have to pay me to do the rework. And so all of a sudden, your cost just went crazy, right? So this is bad stuff. So let's do an example, shall we? It can't be that hard of an example. So congratulations, I work for the city of Lakeland. The city of Lakeland has decided to get very aggressive and impressive. And so we've decided to put all of our intersections on the internet. So what we're going to do is we're going to use internet software to control our intersections. Unfortunately, we don't have any software to do that. So I've come to you. I need you to use your immense coding skills, which don't necessarily exist yet, but I'm sure they are by the end of this semester, to create an intersection control software program. So what does the program have to do? Number one, there should be 3 colored lights that indicate the car should be able to go or stop. Number 2, only one direction should be able to go at a time. Does that sound like a good rule? You guys drive, right? Okay, intersection, one car, one direction can go at a time. Sound like a good deal? I mean, we can let a couple of directions go at the same time. Should we do that?
Yeah.
Okay, well, we'll come back to that. Okay. Pedestrians should be able to cross safely. Okay, there's no points associated with pedestrians, okay? Number 4, if there's a system fault, drivers should be told. Something's wrong, something's wrong, something's wrong. Number 5, don't delay other drivers if nobody wants to turn in a given direction. Oh, I hate that. There's nobody turning that way, why can't I go? All right, so here you go, here are your requirements, go off and design your system. Is that everything you need?
No.
What? I mean, there's 5 of them. 5 fantastically written requirements here. What's missing? Like what? What could you possibly want to know that's not already in that fantastic list of 5?
How big is this system going to be? Is it the entire city, or is it just
It's the whole damn city. So, but why does that matter? That doesn't matter because every intersection is by itself, right?
No. Oh, we're interconnecting all.
Well, I didn't say anything about interconnecting, did I? So now you're designing things that I didn't ask you for. So you just blew your cost and your schedule out, didn't you? Look, I'm just asking for software to handle a single intersection.
But what about other cars who want to go in the opposite direction? If it's an intersection, you got people going from in front of you on the opposite side as well as.
So this, so number 2 seems to have some problems, right?
Yes.
Okay, that's it. So I guess it's only, how would we rephrase number 2 to capture what you're trying to say? Only cars can go in opposite directions at the same time.
Cars crash.
Parallel, is that a good way? What's a better way to go? Don't let them crash, yeah. only collisions can be permitted to occur. So like cars going in the opposite direction. Start in the back.
Will we have to work with hardware too, like pressure pads and stuff?
So are there sensors?
Yeah.
Seems like that'd be probably a pretty good thing. So what was one of the ones here? Don't delay other drivers if nobody else wants to turn in a given direction. Because I guess you'd have no other way to tell that, right?
Yeah.
You'd have to have some pressure pads someplace, right? However those things work, right? Is it one pressure pad, or is it 3, or can you tell if there's just one person waiting, or can you tell if there's a line of car waiting? Because I guess that'd be sort of a different situation. What else information would you like to have for your brand new intersection control program?
There's different times at night.
Oh, time of day. That's a good one, right? Because I guess you could jump rush hour. You would think would be different from middle of the night, right? All right. So you start to get the gist of this one, right? So there's some good requirements here, but it sounds like there's a lot more. And so you, as the software developer, should have a red flag go off when you see just a few requirements, okay? Because clearly there's more going on behind the scene than just what you see here, especially for something that could be as sophisticated as a traffic control system. We don't think about it, and we go through like, what, 20 of them a day and stuff like that. But that's some pretty dang sophisticated software if you think about it. All right, customers who don't know what they want, which is most. So if you're dealing with a customer who doesn't necessarily know what they want, oh my God, what are you going to do? Hold them down, slap them, and say, tell me. No, that's not going to work. So instead, what you can do, you can ask them. So technical professionals, you actually have to talk to people. How does that make you feel? Comfortable, uncomfortable? Because this is actually a key part of what's actually going on. You have to ask them for more detail. You have to ask them for options on how you can implement their ideas. So, you know, an option thing is actually really, really important. When you're talking with the customer, what happens, or what's a good thing to do, is to say, if I heard what you said correctly, here's what I'm planning on doing. Because what do you want to get the customer to tell you? Right, yes, that's exactly what I'm expecting you to do. Well, no, you haven't heard me. You haven't been listening to what I've said, right? So you need to get the feedback from the customer. You need to get the customers to tell you exactly. Otherwise, you're going to go off and design beautiful software that nobody actually wants. All right. Great software development delivers what is needed on time and what? On budget. There you go. I mean, in a nutshell, this is what great software development is. It's easy to say, but it's darn difficult to actually do. Okay. Iteration is the key to software success. So iteration is a powerful word. And what it means is it's a little bit like agile, but basically it means going and talking with your customers. Always making sure that you understand what your customers are actually looking at. So if the blue line is basically our customer requests, and remember our customers are crazy, so they're always adding and removing things that they'd like to have from the software. If we do our sort of big bang software, we'll sort of stay in line, but man, we start to drift, especially as we get towards the end. So we go heads down in developing that software. And what happens is at the end, we'll deliver something, but it's not actually going to be all that close to what they actually want. If we do iterations where we're talking more closely with the customer, you see we'll never be perfect. This is not a perfect world by any stretch of the imagination, but we'll stay a lot closer to what the customer wants. And in the end, we'll actually deliver a product to them that's much closer to what the customer's actually been asking, right? Secret to developing software correctly is iteration. You need to ask, how am I doing at each step of the software process? Customer changed their mind. Oh, I can't tell you how many times that happens. All right? Questions about iteration. All right? So iteration is simply a checkup where you talk with your customer and say, hey, this is what I'm doing, this is what I'm working on, is this, sort of lining up with your view of the world and stuff like that. The customer comes back and says, whatever. So, do you ever know exactly what your customer wants? No. Absolutely not. You need to keep that in mind. You will always be wrong. You'll have a good understanding in your head of exactly what your customer wants, but you are imperfect. You will never quite know. Number 2, if the project is short, do you still need to iterate it? Hey, it's a month. I'll get this software out in a month. I'll do it. I'll show it to you. We'll be good to go. Do I have to talk to my customer during that month? Yes. Yeah, that's great. So it's a short project. You've got no problems with that. Doesn't mean that you're any smarter though, right? And your customer can change their mind in a month just as quickly as they can change it in a week or what have you. So you need to take the time to actually talk to your customer no matter how long the project is. Why not just nail down the requirements before you start? Yeah, I've worked on a bunch of projects where they've had whole departments that try to do that. And very smart people work in those departments, very good, eloquent writers, good talking to customers. They did an excellent job. But the problem is that when you nail down requirements, that's a point in time. That was Wednesday. Today's like Friday. I changed my mind, right? It always happens, no matter what. No matter how well you capture a customer's requirements at one point in time, they will always be changing their mind. Who should gather the requirements? Interesting question. Okay? Look, if you're in a small shop, or if it's just you, then it's you. That's just spooky. All right. So if it's a small shop, it's you. You will be talking to the customers. You will be gathering requirements. If you work for a very large organization, I'll bet you there's a department of people whose job it is to talk with the customers and then come talk with you. And it's their job to turn customer speak into actual things that you can do something with. When should iterations start? So here's an interesting point. This is a rule of thumb. What a rule of thumb means is that it's not nailed in. It's not, you don't actually have to do it this way. But it's a good place to start. So if you're working on a project that's like, let's say, a year long, software development project that's a year long, you should probably meet with your customer roughly once a month. 20 days is actually 20 working days, so drop the weekends off and you're looking at pretty much 20 days is a month worth of work, right? So pretty much at the end of the month, you should plan on having a little talk with your customer and saying, listen, in the last month, this is what I've completed, doesn't line up with what you want to actually have. You do that, you're going to pretty much stay on course. You could meet with your customer a lot more frequently, but you really don't want to do that because when you meet with the customer, does it take up your time? Yeah. Does it take up their time? I think it's time you to go away. Just go away and do some software development. Stop bothering me, right? Okay. And what happens if you screwed up? If you absolutely guessed wrong? Man up and fix it, right? I mean, that's all you can do, right? And you will make mistakes. You will make incorrect assumptions. Customer will say, oh yeah, I never told you that. Yes, you did. Okay, whatever. Doesn't matter. You're wrong. You change. You go. Okay?
They're the ones.
They're the ones who are paying for it. How do we handle like really big software projects, like putting all of the city of Lakeland's traffic control systems on the internet? Well, don't think of it as a large project. That's the secret to it. What you do is you take the really large projects and you break it up into little parts, right? So we take big things, we break them into little things, then we take the little things, and then we're actually able to do the little things. You cannot do a big software project. It is not possible to do a big software project. You are perfectly capable of doing little software projects. And if you do enough little software projects and stick them all together, guess what we call those? It's a big software project, right? Okay, how do we work with the customer? Okay. So we talked about this iteration thing where you do some work and then you go talk with the customer. A good way to view an iteration is just view it as like a mini project. Okay? So what happens is you talk to the customer, you get some requirements. You're going to go off, design a solution, you'll code the solution, you'll test the solution, and then you'll actually have pretty much a done piece of software. If the customer says, yes, that's what I want you to do, you're pretty much done with that piece of software. You may tinker with it as you get it to work with other stuff, but you're pretty much done with that piece of software. You can move on to other stuff. If the customer changes their mind, you're going to go out and make some other changes to it and do stuff like that. But basically, you can view this mini project as being something that you do over and over and over again as part of a full-up software development project. And each one of these cranks out a little piece of working code that eventually, when you put it all together, goes back to that big project that we were just talking about, right? How to manage requirements. Oh, man. Okay, so how many requirements are you going to have for a software project? We have to come up with a number. Depends on the software project, right? I mean, it could be as simple as 10, or it could easily be thousands. Build me a fighter jet. Okay, that's going to be a lot. Okay, now the problem with requirements is that you will get easily overwhelmed. I mean, how many things can you keep in your mind at one time? One! Here, this is good. No, but so specifically, you can keep a few things in your head, but you certainly can't keep all the requirements for a software project. So you need to write them down. You can get out a piece of paper, you can write them down, that's perfectly okay. What we have found, voice of experience here, is that it's generally going to help you if you write them down, probably on a separate card. Because then you have all these requirements and you can sort them and do things and put them in different orders and you can remember what they are. And you can take them out when they're done. You can do all sorts of things. You want to give each requirement a name. So I'd like to have a traffic control system for City of Lakeland. I should be able to have cars move in 2 different directions at the same time. I don't want to have to wait for somebody if there's nobody in line. Those are all great requirements. I got to give each one of those requirements a name so I can remember that it's something to do. If you just give it to me as a paragraph, Have you done that paragraph yet? I have no freaking clue. There's like 20 requirements in that paragraph, right? So break them out and give them an individual name. It's going to help you a great deal to determine, are you done? Have you gotten that software done yet? I'm not actually really sure. That's a big paragraph, right? If you take the paragraph, break it into 20 requirements, then when you get half the requirements done, you can say I'm halfway done. And when you get 20 requirements, then you can say I'm all done with that. It makes it a lot easier. Create an estimate for how long it will take to design and code this requirement. We'll talk about that here in a little bit. And then determine the customer's priority. So this is actually probably a good point to end things up on today. So look, if I'm a customer and I give you 100 requirements, are all those requirements equally important to me?
Not necessarily.
Absolutely not, right? Are some of them really, really, really important?
Yes.
Cars should not crash. That seems like a good one, right? Are some of them not so important and sort of, let's call it a nice to have? Yeah.
Not having to wait.
Correct, that's exactly correct. So, which one should you get done first?
Not having crashes.
Okay, right, the most important ones, and by the way, when you deliver the software to me, what's going to be most important to me is that the important stuff's there, right? Remember, these software projects can get away from you, and you can start to slip in your schedule. And if you have to deliver software to me on a scheduled date, that software had better have the really important stuff in it, right? I can give you a little leeway if it doesn't have some of the features that aren't all that important to me. We'll talk about how those get worked in later on. But you better have the important stuff in there, right? So, before you start your software project, you best be having a talk with your customer. And you best be having a talk with your customer about where their priorities are. Because you need to know which one of those requirements you need to work on first, because they're of the highest priority to your customer. That make sense? Okay, our intersection example again. So these are all the same things that we saw. So red, yellow, green lights, right turn arrow, left turn arrow, multiple lights in the same direction, traffic-based scheduling, flashing yellow fault, right and left green light. What we've done is we put them on little cards. Pretty cool. How about that? We give them a little title, just like we talked about. That's fantastic. What I've also done is I've actually put a software estimate. 12 days to do this one, 3 days to do this one, 3 days, 4 days, 20 days. Oh my God. 2 days and 6 days. And I've also put a customer priority. Customer has 2 priority, 1 requirements. Which ones are they?
Basically, with the light.
Exactly. Right. So for whatever reason, crazy customer, they decided those were the most important ones for them. Okay, they've got some 2s. What's the lowest priority requirement here? Right, left and right arrow circle. And what priority are they? 4. Exactly. All right, so I mean, they're still relatively important, right? I mean, I think 5 was the lowest, but yeah, these are whatever. Great. So if your customer gives you this, now how long do we say we wanted to go before we would interact with the customer? Go back and check with the customer. Every 20 days-ish, right? All right, so here are your requirements. Here are your estimates for how long it's going to take you to develop it. What are you going to work on during the first 20 days? Which ones? What? Which one? Give me titles. Give me titles. Okay, so this one you say you're going to work on during the first 20 days. Is that it?
No.
Okay, what else are you going to work on? Down there. Is that it? So you're going to work on those 2 requirements during the first 20 days. Is that correct? We're all done? How many days are we using up? So we're using up 12 and 6, which comes out to be what, 18 days?
We could do the flashing yellow fault. It's not the highest priority, but it's also fits in that time schedule.
That's true. So another 2 days and we roll up to 20, right? Okay, that's cool. All right, so great. You got your first 20 days done. You got 3 requirements you're going to work on. Now what are you going to work on during the next 20 days? Oh, so you think this one? And it's going to take up the whole time period, isn't it? Okay, cool. So it's going to look something like this, right? So during the first 20-day period, you as a software developer are going to work on 3 people named 3 features, right? Pow! End of the 20 days, you go to the customer and you say, look, I'm going to show you how the red light, yellow light, green light thing works. I'm going to show you how right and left green light and flashing yellow works. Is this what you wanted? With a little luck? They say yes. Or they say you got pretty close. Change a couple things, but you're pretty much on the spec. And then we're going to spend the entire second development period working on what? Exactly. However that is, man. That could be complicated stuff, right? At the end of that time period, we'll go show it to them and see if they're cool with it. So you start to get the gist of it. So I've got requirements. The requirements have priorities. These requirements all have a certain amount of time that they're going to take me to develop. And I want to meet with my customer every 20-ish, whatever, days, right? So what I'm going to do is come up with a schedule. This is I'm going to work on the high priority stuff first, lower priority stuff second, and I'm going to try and get together with my customer every so often. That all make sense?
Yes.
Seems pretty reasonable, doesn't it? Okay. All right. How much iteration is too much? Hey, stop calling me, is what your customers eventually going to tell you, right? So look, concept is that you're trying to save your butt. You're trying to make sure you don't do anything incorrect the customer doesn't want you to do. So you want to meet with them as often as you can. You don't want to piss them off too much and stuff like that. The most important thing, what you got to understand, is it's always better if you can deliver some functionality to your customer that works perfectly. Okay? And if you can't get it all in there, then we move on and we'll come up with a plan for it. The one thing you don't want to do is deliver all of the functionality to the customer and have it all not work. Or deliver functionality that doesn't work, right? You don't want your customer coming back and going, well,
The ambulance crew's been pretty busy today, unfortunately, because apparently you turn all the lights green for a little while every once in a while.
no, that's not good. Right, so we don't want to do that. If customers change their mind, and of course this is going to end up changing your project. And as a software developer, you need to be ready for that. Man, I wish you lived in a great world where customers give you requirements, you go off and you do software development, you deliver to them, and they give you a check. Fabulous, that's a wonderful world. We do not live in that world. That does not happen that way. And what that means is that you have to adjust how you develop your software to deal with the real world. Okay, what did we cover today? We discovered different ways to create software code. We discovered why the Big Bang, although a cool television show, does not actually work in the world of software development. We discovered what iteration is and why it's needed so that you can stay on track and how to manage requirements. That sounds like a pretty good way to spend some time. What are we going to do next week? What to do when a customer adds new requirements? Damn, they can't do that, can they? Did they promise? Oh, okay. What is the software development process? We'll go over that. And when is a software development project actually done? When you got it? No, okay, cool. All right. 15 minutes, 5 after, come back, and we'll talk a little bit about Python. Sound like a plan?